Greetings everyone. I am Udaysharma from the Tripoli Department of Institute of Aeronautical Engineering. Today, I am going to discuss about the topic VI characteristics of a PN junction diode. Let us discuss what is a diode. A diode is an electromagnetic component with two electrodes that allows electricity to go through in any one direction, that is, either to positive to negative or negative to positive, not the other direction. Diodes can be used to turn alternating current to direct current, AC current to DC. A diode has two terminals. The positive side is called anode and the negative side is called cathode. Semiconductors like germanium, silicon are used to make most of these diodes. A PN junction diode is a two-terminal. PN junction diode is a two-terminal device which allows the electric current in only one direction. As it is a diode and its basic principle is to allow current to only flow in one direction. The same follows the PN junction diode, while blocking the electric current to the opposite direction or reverse direction. In a semiconductor, a PN junction is an interface or border between two semiconductors material types, namely P-type semiconductor and N-type semiconductor. P-type semiconductor and N-type semiconductor. The junction between these two types of semiconductor is called as P-N junction. When an electricity is or any external source is supplied to the PN junction, depletion region is formed. That is, when the positive elements from the P-type and the negative elements from the N-type try to flow from each other. When the positives try to flow to the N-type, they form a layer near the N-type. And when the negatives flow from N-type to P-type, they form a layer at the P-type. The layer of these electrons is called as depletion region. The voltage applied determines one of the three biasing conditions for a PN junction diodes. There is no external voltage provided to the PN junction diode when it is called as zero bias. As said, if the P-type and N-type, there is no external voltage supplied, it is a zero bias. When the P-type is linked with the positive terminal and the N-type is linked with the negative terminal, it is a forward bias. The P-type is linked to the positive terminal of the voltage potential, while the N-type is connected to the negative terminal. It is called as forward bias. For reverse bias, the P-type is linked to the negative terminal of the voltage potential, while the N-type is connected to the positive terminal. This reverses to negative and positive. The PN junction is said to be the forward bias and the P-type is connected to the positive terminal. As we can see here, the positive terminal is connected to the P-type and the negative terminal is connected to the N-type. Of the battery, negative terminal, the built-in electric field of PN junction diode and the electric field are in opposing directions, while the PN junction is forward bias. As a positive electrons and the positive supply and the positive charges repel each other, they tend to move towards the N-type, and same follows for the N-type. The negative terminal and the electrons tend to repel each other and move towards P-type. Here, the depletion region is formed. The PN junction diode. The depletion region for a forward bias is less. For PN junction, to reverse bias, for PN junction in a reverse bias, The P type is connected to the negative terminal and the N type is connected to the positive terminal. The depletion region here is large. The positive charges moves towards the negative charge and the negative charges moves towards the positive terminal. The few electrons and few positive charges tend to flow in the opposite direction. They form a large depletion region. The PN junction diode, the reverse bias, the P type is linked to the negative terminal. The N type is attached to the positive side. The applied electric field to built-in electric field are both in the same direction. Let us see the VI characteristics based upon the following P type forward bias and reverse bias. The curve between the voltage and the current across the circuit defines the VI properties of PN junction diodes. The x-axis represents the voltage. This is a voltage. And the y-axis represents the current. The characteristics of the shown in the PN graph. As we can see here in the graph, this is a part where in the forward bias, P type, N type, and depletion region. The energy takes for the breakdown of the depletion region for the for the voltage or the charges to move this direction. And this is a voltage spike once the charges when the depletion region is removed. Same as here, as the depletion region in reverse bias is large. It takes much time and it gives a spike after the breakdown voltage. The PN junction diode is forward bias. The P type is linked to the positive terminal and the external voltage, while N type to the negative terminal. The potential barrier is reduced when the diode is placed in this fashion. The current grows slowly while the diode is under forward bias. The curve formed is non-linear as the voltage supplied to the diode overcomes the potential barrier. Once the diode has crossed the potential barrier, it functions normally and the curve rises quickly. The external voltage rises. As discussed, it takes time, it takes slowly, and external voltage rises after reaching the barrier. For a reverse bias, this becomes reversed. When the PN junction diode is under negative bias, the P type is linked to the negative terminal and the external voltage and the N type to the positive terminal. As a result, the potential barrier becomes higher. The depletion region is higher compared to the P type or the forward bias because minority carriers are present at the junction. Reverse saturation current occurs first, and then after breakdown voltage, the voltage spike occurs. Applications of a PN junction diode. The PN junction diode is arrangement is reverse bias. The diode may be utilized as the photodiode since it is sensitive to light. It has potential to be utilized as solar cell. The diode can be utilized in the LED light applications when it's forward biased. Many electrical circuits utilize it as a rectifier and reactors employed to the voltage controlled oscillators. Thanking you. This is Udaysharma signing off.